From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 275, recorded live Thursday, July 14th, 2011. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Dan Fernandez about the Microsoft Research Kinect SDK.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. And today we're talking with Dan Fernandez. I want to understand the Kinect for Windows SDK because it's a really interesting device, and Dan knows all about it. How's it going, Dan?
Hey, wonderful.
Glorious. So help me understand this. The Kinect came out. Everyone said, wow, this is amazing. They immediately started hacking it. The public waited for Microsoft to sue the crap out of everyone. And instead, we come out with an SDK. What's going on?
Well, it wasn't actually, I have to do the Miguel de Casa. Well, actually, people weren't really hacking it. What they were doing was the way Kinect works, it sends its raw data through USB. Mm-hmm. So they were just basically understanding the stream of data and then using that for applications. Now, there is a company that Microsoft partnered with called PrimeSense, and they actually built an API, because a lot of the technology is from the folks at PrimeSense in terms of the actual device, and you can read the whole press release when we originally announced Project Natal around that, but a lot of that technology is from the company PrimeSense, and they've actually released an SDK that works with Kinect as well as their own device as well.
Okay, so everyone's saying Kinect hacks, but really what they mean is that, the public didn't expect that. It's a series of cameras. There's a lot of information, but it is just over USB. So it's not really.
So think about it this way. So one, just kind of give folks an overview of what you can do with the Kinect, just in terms of the surface area of the API. So the first thing the Kinect has is an RGB camera, mm-hmm. and this basically sends still images. It's about 30 frames per second, and the idea is you as a developer can get sort of like the still image of a particular scene. And this is just a regular image, and when you start playing that at 30 frames per second, it looks basically like a live video stream, mm-hmm. Okay. Right? So nothing very fancy there. The next thing is a depth camera. So the device has basically shoots out infrared data, does some stuff with IR filters. I won't get into all the algorithms and stuff that goes on there, but what it does is the depth camera gives you the same picture, but instead of say the color value of a particular point, like hey, at 0.00, this is the color, it gives you the distance. So you know the distance of every point. So like in a 320 by 240 image, you're going to know the distance of every single point.
Okay, so let me see if I understand. There's two cameras, and it's sending me the same frame twice. Here's, at pixel 100, this is red because he has a red shirt on. Right. And at pixel 100, he's about 6 feet away.
Exactly right.
Okay.
The idea is, and that's the raw data that's sent over. So, as well as with audio, and actually the Kinect for Windows SDK also is the first, of these toolkits, and there's been a lot of excitement around open source because this is the first one that actually provides audio APIs. And then, so then the last thing is you get this raw data. That raw data is interesting if you want to work on it at a low level, but from a higher level perspective, this is where the magic of software comes in, and what the Kinect does is interprets that depth data and actually does skeletal tracking. So give me all the distance data, and based on this, what I'm going to do is figure out what the skeletons are in a particular scene.
So
in that sense, if you're the person that's 6 feet away, I'm going to know where your head is I'm going to know where your hand is. I'm going to know where your wrist is. I'm going to know where your shoulders are and all that.
Okay, so this is where I want to understand more. I can get my head around there's two cameras, and I believe that the depth camera, like you said, it shoots out IR. Basically, it's like a bunch of tiny remote controls shooting at you, and then they bounce back and it determines depth. And then you lose me at the skeleton part. Yeah,
so it's the challenge is it actually does some stuff in an IR filter and lens, and it's not time of flight is one thing to point out, which is the typical when it bounces back and times it. It's a different technique that's actually cheaper.
Okay.
Because time of flight devices can be very expensive for a good implementation. But like I said, it's kind of complicated how it actually all works. But it shoots dots, and then based on the angle of those dots, it can determine depth data. There's a good article on electronic design, but like I said, it's pretty. There's a bunch of algorithms around laser-induced differential absorption radar, which is called LiDAR, but at a high level, you get depth data, and that depth data is the distance. So just from a developer perspective, you just get depth data back.
I get some number that represents an arbitrary relative depth, or I get an actual. It's 6 feet away.
Yeah, it's a distance in millimeters from the Kinect.
Ooh, wow, millimeters.
Yes.
Okay, that's pretty accurate. All right, so I get that. I get that part. Who is doing the skeleton part? Because I'm trying to understand that I realize that there's, for the overall kind of Kinect experience, the overarching experience, there's some hardware, there's some work happening on the Kinect, but there's also work happening on the Xbox, or in this case, when I plug it into the PC on the PC. When you talked about the skeleton part a minute ago, who's doing the skeleton work? Who decides that's my head?
Yeah, so the socket on a chip Xbox part and all that stuff is the part that's giving you all the depth data. At that point, we take that data and turn it into information, and that part is when you install the Kinect for Windows SDK, or if you have an Xbox, in one of their updates, it does all the software for you. So it's a software problem at that point to take the raw data and turn it into, hey, there are 2 skeletons in this room, and here's every joint position.
I see. So that's kind of the secret sauce.
Yes, that's the magic of software part.
Okay, so the Kinect SDK includes drivers, right? Like if I help me understand this. When I plug the Kinect into my computer without the SDK, what happens? And then what does the SDK add?
It says it's like unknown USB device. Do you want to search Contact Windows Update to see if there's a driver?
Okay.
That's what you currently get. When you install the SDK, it does hey, there is a USB device, and that USB device is sending this raw data, and here's how to communicate with it. Both ways, because you can actually send commands to or at least basic commands to the Kinect device itself. For example, to tilt the device, you probably see this on your Xbox where it kind of scans the room automatically.
Right, it does a little head nod, a little Johnny 5 head nod every time it turns on.
Yeah, so that's something that's not built into the Kinect for Windows SDK, but it is exposed as an API. So you can pretty much do, I think it's a range of -27 to +27, and that's degrees. So you can say, like, whenever your application starts up, scan the room, and then find out, maybe it's skeletal tracking, you can find out the best, if there's any skeleton joints that are being clipped or not being represented. Maybe if they're being clipped at the very low angle, then maybe that means the Kinect is actually on top of a TV. Or if they're being clipped, another place, maybe you can't see the head, then maybe change the angle so that you can see the most joints possible.
Okay, now is that something that I need to do the work on?
Yes, that is something that you need to do the work on. And I will say the Johnny 5 effect, if you will, of tilting it, is not something that's designed to do a lot. I think it's there's a certain number of movements. I want to say it's a handful within 2 minutes or so. So it's something where you probably just want to scan once when your application opens up.
Okay.
as opposed to, making it be a headbanger's ball, if you will, where it's constantly going up and down. It's just not rated for that, and it'll just stop taking commands.
I'm hearing you say that it's cool that I can move it, though, but it's not particularly useful for my application.
Well, it would be useful because you don't know where somebody has placed the Kinect.
Oh, okay. So you give me the skeleton information. I move the head around looking to make sure that the head and the feet are both within the space, and then I might say something like back up.
Yeah, so the way I've just built like a very dummy version. So the skeletal tracking, each joint can give you basically its tracking state. For example, whether it's being clipped, maybe it's like not visible, like your left elbow's out of the visible range, or whether it's not it's not tracked at all. Say, for example, if it's on top of a desk and it can't see your feet, or even your knees, right? So if you do a full scan and basically where all the joint positions are, you can say like, oh, okay, I got all 20 joints at this degree, for example.
Okay. So then if my application needed to see your left elbow and it couldn't, I might adjust the angle, but I would in fact need to say, hey, you pause the game. Hey, FYI, I can't see your elbow.
Yeah. And I mean, folks who have played with Kinect have probably seen this where the game will tell you, that you're being clipped or you could then show an animated arrow to move to the right, if you will.
Mm-hmm.
So that people know to move into an area where the Kinect can actually track you.
Okay, that's very helpful because it gives me a sense of what's the Kinect's job versus what's my job.
Right.
Now, this stream of depth data that comes in, is this a video frame that I'm supposed to do something with?
Yeah, so I mean, at the from the actual USB device to the Kinect SDK, by the time you get in the Kinect SDK, you are getting what's called a planar image data type. Okay. So basically, it includes the actual, it's a red, green, blue, and then the actual values that you then need to convert into an image. So it's a byte array. So let's say it's a 640 by 480 byte array. You're now converting that into an image. But since that's kind of a repetitive task to do that, and using WPF, it isn't that hard to do that for a regular image. You're just using I think it's a create bitmap source call. We did, for coding for fun, we just built a series of extension methods to do this, which is if you give me a planar image, I will call to bitmap source and actually convert it for you.
Okay, so that makes me think that while the SDK is complete and there's a lot of cool stuff going on, there's still room for stuff for us to add as the community. So I mean, you right off the bat, even though you work for Microsoft, you're like, wow, we found ourselves taking the depth data and turning it into a false color image all the time. We'll make a helper for that. Then there's other things for us to do. Yeah.
Absolutely. So, and actually, you know what? The extension method is on the image frame, because the planar image, you need the size data, or I forget exactly what data is within the planar image. But basically, when you get an image frame back, you call to bitmap source on it, and at that point, I can say, let's say I had a WPF application with an image on it. I'd say image1.source. There's an event that I'd register to get a new image, and I'd just say, from that event, it'd be e.imageframe.toBitmapSource.
Okay.
So it's basically one line of code to convert that. And one of the reasons they did that is to not have to make it presentation layer agnostic. In other words, there isn't a WPF library in the Kinect for Windows SDK. There isn't a Windows form or, even a console or whatever. They give you the raw data that then you convert to, say, XNA, to WPF, or to whatever. So on the Coding for Fun side, we've done at least WPF and Windows forms.
See, that was my next question, because you keep saying WPF, and maybe I want to use C++, or maybe I want to use something else.
Yeah, so I should say that the Kinect for Windows SDK is available for regular .NET languages, if you can reference the libraries, you should be happy, as well as C++. But there aren't C++ libraries to handle the visualization of that data. Right, so it's not choose your C++ UI toolkit language. There isn't a representation of that.
Okay.
You get the raw data and then you convert it back into whatever library that you're using for C++ UI.
Okay. And the data that comes out of the Kinect, I've heard 320 by 240, and I've also heard 640 by 480. Which is it?
It actually depends. So, you can get, there's a call for get valid resolutions inside the Kinect SDK, and in general, the depth camera, I think it's 320 by 240 is the highest, and the color image is 640 by 320 by 240, 640 by 480, and I think there's a 1024 by 768, and they actually, I think on the software side, do some stuff to convert it into the higher resolution.
Okay. I remember that.
And again, a lot of this stuff is based on the XDK that you can think of the Kinect for Windows SDK as its starting basis was using the XDK that's existed for a while, and then we built the managed wrapper on top of it and tried to do things in a more managed style, if you will.
Okay. Would you expect that someone who's using this SDK would definitely want to use managed code? That the idea that I might want or even need to use C++ is not really necessary?
Yeah, I mean, unless you're building a C++ app, there's no need to use C++. Like, in other words, there's no secret part of the API that isn't exposed via C++.
Okay, that's kind of.
And I think the majority of apps I've seen so far are using C# or VB, but that may just be a factor of there's more C# VB enthusiasts than say C++ folks, which tend to focus more on hardcore ISV apps.
All right, I gotcha. Okay. When I plug it into the PC, can I start doing things like controlling windows around and doing all that kind of Minority Report type stuff?
Yeah, so at that point, so let's say you download the Kinect for Windows SDK. It installs a bunch of drivers. You plug it in. You're going to get this blinking green light that lets you know, all right, it's now working. You go into Device Manager. You'll see a way to see the motor, the camera, and audio. At that point, Kinect is working. You now need an application to do the real work. So one of the things we did was our good friend Brian Peake, who I should introduce you to because you've met him 10 times.
Yeah.
He built a cursor application. So, and I think it's Kinect Cursor. Or you know what? I think it's mouse.codeplex.com.
Are you trying to look it up right now?
Or maybe connectmouse.codeplex.com. But basically, think about it as it's connectmouse.codeplex.com. It's a cursor that allows you to use whatever hand you want, right or left hand, as a cursor in Windows.
Wow.
So if you want to left click, if you want to drag and drop images, it's an open source Codeplex project, but it just gives you the basics of, hey, wouldn't it be cool to, maybe surf the web, scroll a web page, all using, or in Outlook, drag and drop, an image into a folder or something like, or an email into a folder.
This episode of Hansel Minutes is brought to you by Careers 2.0. Careers 2.0 is a new service by our friends at Stack Overflow. You're probably all familiar with Stack Overflow, the online Q&A resource dedicated specifically to programmers and programming-related topics. Well, the team at Stack Overflow created Careers 2.0 to provide you with access to great jobs and introduce you to a bunch of great companies that you might consider working for, even if you're not currently looking for a job. Think of Careers 2.0 as a programmer profile. It gives you a platform to show that you're awesome by featuring your proudest contributions to Stack Overflow, GitHub, SourceForge, Bitbucket, anything programming related. You can even add your favorite programming books from Amazon.com. Profiles on Careers 2.0 are free. They're easy to get started, especially by importing your LinkedIn profile. However, there's one catch. Profiles on Career 2.0 are invite only. They did this to keep out the spam and have a high-quality environment. Fortunately for you, as a Hansel Minutes listener, I've got your back. Head on over to careers.stackoverflow.com/HM to accept your invitation today. Once again, that's careers.stackoverflow.com/HM. I hope you like it. Since you've worked with this for a while, you've spent quite a bit of time with the Kinect SDK. Do you think that it's pretty accurate? I mean, some people have said that it's amazing and like they can't believe it can see their fingers, and other people have said for them it just seems a little shaky and it can't see their arm. What do you see as far as accuracy, and what makes it more accurate, and is it getting better?
Yeah. So one thing to keep in mind, and this is actually a really good point, is the skeletal tracking. Just by default, because it's software-based, will have what you'd call jitter, right? So, like, imagine you are tracking, a hand or an elbow. There may be a time where it moves, say, 10 or 20 pixels, or maybe even not that much, 3 pixels or something, and it just, like, kind of jumps off. So if it's giving you that data of a specific joint, like the middle of your hand is at, let's say, 100 by 100, and then all of a sudden there's 105 by 105, and then 97 by 97, and it looks like it's kind of moving, and that's where you get people saying, "Hey, this is, I'm getting jitter. What's going on here? It doesn't seem that accurate." So one way to do that, and what's built into both the XDK that ships with Xbox and into the Kinect for Windows SDK is smoothing. So the actual algorithm is a double exponential filter. But just at a high level, what that does is filters out, and you can control this, pretty fine-grained control on how you want the data to smooth out. So that way, if there is something, just one random, let's see, out of 30 frames per second, there's something that's 4 pixels off, it'll be a almost like a smoothing average, except it expires exponentially, if you will. I won't get into details of the actual algorithm, but if you search for, exponential smoothing on Wikipedia, you can see some of that stuff. But the point is you can control kind of the noise, and that helps you remove the jitter so that it feels more accurate. It feels like where your hand is. It feels like as you move left to right, it moves better. And we use that in both, let's see, we have the Kinect Mouse app and a Kinect Paint app. And since you're using your hand as a cursor, you want it to feel like move those jitteriness, because without those, and you can do kind of like A/B testing, just comment out the exponential smoothing, and then do it with, and you'll see that it just feels like it's tracking better, if you will.
Ah, okay. So So the hardware is, I wouldn't say making a mistake, but the hardware is misinterpreting something and then the software fixes the error?
Well, technically, it's you're talking about skeletal tracking, it's all software. Right? So skeletal tracking is software. Depth data and camera is the raw data from the hardware. So from the software, it may be tracking something differently. It may be readjusting things for whatever reason, and then what this allows you to do is, because there's so much data being sent, you're getting this data at 30 frames per second.
Right.
If there's inaccuracies around those, it can do the just basically removing the noise, if you will.
I see. Because it's interesting because, I mean, it's all digital, but there's this analog aspect of things, which is our bodies themselves.
Yeah.
An analog is never 100% accurate.
Yeah, absolutely. So I think one of the things is you want at least when you're starting to work with applications today, with Windows, depending on your screen and your resolution and stuff, it can be kind of a pain to click into something that has a really small hitbox area. Right? So if you're going into, you press start, you go into programs, and you're doing it to nested windows,
right,
it can be a pain when you don't have the level of granularity control. And I think that's actually something that is much more difficult to use for Kinect for when you need to do those like really small precision movements. A mouse is absolutely the best way to do that, even better than, fingers.
Yeah, I think that the dream is that we'll have mouse level finger accuracy a foot away from the monitor, right? I mean, I know that I want whatever the next version of Windows is to have built-in Kinect support where I can put my finger out and it'll just know that I want to move that window onto that monitor. Like, that would be awesome.
Yeah, I think what you'll find is you won't want it for everything, but to be able to, and they call it multimodal, where, for example, let's say, just arranging windows, you probably have 4 monitors. Most of us have 2 at least for developers. You would, for example, just use hand gestures to, say, move windows around, and not necessarily for every single thing you're going to do in Windows, but just for certain tasks that it works really well for. Or, for example, for zooming in and out of data or certain types of data, maybe it's pictures or whatever it happens to be. I don't think it'll replace the mouse, but I think it'll complement it. Is maybe my suggestion.
I see. I think that we want to see official support, which would be really exciting. It's one thing to have it plugged in, but to really have this thing be allowed, or even integrated, be a fundamental part of Windows would be amazing. Now, one thing I've noticed with my Xbox Kinect is that every once in a while I'll get an Xbox dashboard, something minor, and it'll say updating device. So somehow the Xbox Kinect gets an update from the cloud and, like a little firmware or something like that. Do you know if the SDK will update the Kinect also?
I don't know of a plan to. And when it says updating device, does it actually mean the Kinect, or does it mean your Xbox?
I don't know. I just know that a little dashboard update comes in and it starts nodding and moving around, and I'm just wondering if they're actually talking to the Kinect, or if the Kinect really is just cameras.
Yeah, so I mean, there technically is a way to upload firmware, but for example, things like speech recognition, and in fact, we haven't talked about speech as another big capability, but the speech recognition, the way to interpret a language, the actual language pack that's used on Xbox has been, we've made it available to download for Windows users as well. But all that stuff is running on the Xbox or on your PC, not in the device itself. Mm-hmm. So that again, I suspect that given that stuff, let's say there's an update to language packs to add a new language, or to update the grammar for Xbox. Let's say they add Netflix voice commands or something, they're going to need to upload the new set of commands that you can say Xbox or and then give a particular voice command to. So that's what I would expect from device updates.
I see. And speaking of voice commands, what is the voice recognition support for the SDK? Because I understand that people keep saying that the microphones in the Kinect are like amazing. That not only do they know that you're talking, but they know where you are in the room. Yeah,
so just at a high level, the way there's kind of 2 ways people use audio. One is to kind of just use it as a microphone, and the cool thing is the Kinect actually mounts as a full microphone. So, for example, if you are the next time you're on using an audio application, and I was going to say Skype, but you can't actually use it with Skype. There is an issue using it with Skype. But next time you're using, say, Sound Recorder, just a plain old Windows Sound Recorder, you can choose a microphone and choose the Kinect as your microphone. So it mounts as a microphone array. Windows sees it as a regular microphone array. and you can treat it as a regular microphone array to, say, record sounds in existing applications, or, with your application's recording sound. So in addition to that, there are, you can use the speech recognition engine to actually build speech-enabled applications. So one is, if you're using, Windows 7, because you do need Windows 7 for the Kinect for Windows SDK. If you're using Windows 7, it ships with speech recognition. So I don't know if you've ever gone into accessibility and turn on speech recognition.
Sure, all the time, actually.
Sorry?
Yeah, all the time. I've done a lot of work with speech recognition. I even wrote my first book for Rocks using Dragon Naturally Speaking. Okay,
so the built-in Windows speech recognition, where you can say, like if you have multiple windows open, you can say switch to and then say Notepad, and that would switch to Notepad. That just works. So there's no code. This is just using features in Windows 7 after you plug in the Kinect for Windows SDK, because it's treated just as a regular microphone. Now, when you're building your own application, so let's say you wanted to do voice commands for PowerPoint to go to next slide or previous slide. At that point, you need to build an application. You're using the existing speech recognition APIs. So we actually ship two sets of APIs. One is the one that ships regularly with the .NET framework, which would be .NET Framework 4.0 on most machines. And that one's probably a little behind in terms of features. Then we ship another version, which is like the more updated version, and that's the one we tend to be pointing people to. And I think it's under Microsoft.speech versus Windows.speech. But the point is, just using those APIs for speech recognition, you create a grammar, which is, hey, start listening to audio and wait if somebody tells you this command. And this command will be, say, next slide. If you hear the word next slide, then, current slide plus, if you will. Right, and that's basic at a really 10,000-foot level how speech recognition works. It waits for a certain set of commands, compares the audio against those commands, and then you can take a particular action.
Okay. Yeah, it's interesting to understand again where the software ends and the hardware begins. It was interesting to me to think about what the Kinect's job is, and then what the algorithmic work that's being done downstream is, and the same thing, what value that the hardware provides in quality, in a quality microphone array. It would be really interesting for me as someone who works remotely and tries. I have 3-4 different microphones here that I all kind of move between when I'm Skyping. I'd really like to hear the quality of the Kinect, and as an array mic, if I could even pace around and get better quality than a speakerphone, that would be really cool.
Yeah, I think you should definitely play around with it and let me know kind of your results, because I think you're probably on would be a heavy user, for lack of a better word.
Yeah, definitely a discerning user at the very least. Thanks for sharing. Tell us where we can go to get the coding for fun stuff as well as the SDK itself.
Yeah, so if you go to research.microsoft.com, Kinect SDK.
Okay.
And then let's see, I'm being put on the spot on the Kinect one. We do have a series of Kinect for Windows quick starts actually that I should make sure to plug. And that's channel9.mcn.com/series/Kinect SDK quick starts. And that is everything from installing and using the Kinect sensor, setting up your dev environment, basic skeletal tracking, using the depth cameras, that high level stuff. And then let's see, C4FConnect.codeplex.com is the Coding for Fun Kinect toolkit, and that includes extension methods for WPF and Windows forms. Includes some basic things like a tap and hold button that you can use in WPF for, say, selecting something, and some other low-level things to work with the depth camera as well.
Very cool. And do I have to buy an Xbox to do this, or can I go buy a Kinect by itself?
Yeah, so you can buy just a regular Kinect by itself. And in fact, the one thing you do need to do, if you got a bundle, you may not have a regular USB cable. Basically, if you have a power cord for your Kinect, and the power cord plugs into the end will be what kind of looks like a USB, but it's actually is missing a corner, and it's orange in there. That is not a USB. You can try and force it into your USB port. It won't work.
Okay.
There's a connection, and if people don't have it, they can go to the Microsoft Store and buy it. But that includes basically a power plug and a converter to make it into a USB. But if you buy the regular standalone Kinect, then you can just use it with no issue. Okay,
so then the one I have has USB, but if I bought a bundle, I need an adapter.
Yes, although I think there may be some bundles that technically have that adapter, but I think as a general rule, if you don't have the power adapter, then you need to buy it.
Okay, cool. Well, thanks a lot, Dan. I appreciate it. Getting me up to date on the Kinect.
Thanks. It's been great.
This has been another episode of Hansel Minutes. We'll see you again next week.